Hi there. Question 7. Strontium chloride, which is an ionic compound, is used in toothpaste to reduce sensitivity. State the term used to describe the structure of strontium chloride. Well, there are 4 structure things that you have to remember, and they are ionic lattice, covalent network, metallic bonding, and covalent molecules. So your main problem is probably going to be distinguishing between the word lattice and the word network. So you get ionic lattices and covalent networks. I'll just write both and show them to you. Ionic lattice, covalent network. And when I see covalent network, I think of a coal network, like a network of trains moving coal. And when I see ionic lattice, I think of an ionic lettuce, because a lettuce with full of ions that would be good for you would be an ionic lettuce. That's why I had that little slip there when I said ionic lettuce instead of ionic lattice. Obviously it's ionic and it's a solid, it has to be ionic lattice. A sample of strontium chloride was electrolyzed. State why ionic compounds such as strontium chloride conduct electricity when molten. And a really brilliant phrase to memorize is because the ions are free to move. But you probably want to put that more in a sentence. Strontium chloride can conduct electricity when molten because the ions are free to move. When I'm copying from the question. Go. Part 2. During electrolysis, chloride ions lose electrons to form chlorine gas. So the chloride loses electrons. So that's probably where you want to use oil rig. Oxidation is loss, reduction is gain. Chlorine ions lose electrons, it will be oxidation. So I'll just write down oxidation. And then as a little check, metal ions, when they are reduced, it's reduction. And that's on the back page of this data book. This is reduction and these are all metal ions. So chloride ions, being halogens on the other side of the periodic table, when they get turned back into chlorine, that's probably not going to be reduction, because that's what happened to the metal ones. Is probably going to be oxidation, just because it's not reduction. That might be another way to think of it. Explain why a DC supply must be used. Don't say because you need a steady current going to the electrodes. Do say because to ensure that only one product is produced at each electrode, which I shall just show you rather than write because I'm lazy. To make sure that only one product is produced at each electrode. Thanks for watching. Bye.